If you're running a network, you know that trust is absolutely everything. So today, we're going to dive into a security measure that's all about building that trust, EIGRP Authentication. And let me be clear, this isn't some optional nice-to-have. This is essential stuff for protecting the very heart of your network. I mean, really think about that question. Without authentication, your routers will happily become neighbors with any other device out there that happens to be speaking EIGRP. And that opens a huge door for someone to inject bogus routes, either by accident or on purpose, and bring your whole network to its knees. So the real question is, are you just going to let that happen?
Okay, here's our game plan. We'll start with the why this is so critical. Then we'll look at the old security methods versus the new ones. After that, we'll get our hands dirty with the actual configuration. And finally, we'll wrap up with some pro-level tips for managing your security keys like a boss.
All right, first up, let's lock down the fundamentals. Why do we even need to do this? Well, it all comes back to making sure your routers aren't taking bad directions from some random unauthorized stranger on the network.
And hey, you don't have to just take my word for it. The Center for Internet Security says it plain as day. Authenticating your routing updates is how you stop your network from getting poisoned by bad info. This is foundational stuff, folks, not an optional extra. So, what are we really doing here? At its core, EIGRP authentication is basically a secret handshake between routers. Before they agree to swap any routes, they check each other's credentials using a shared password or key. If the keys match, awesome, you've got a trusted neighbor. If not, that update gets dropped, no questions asked. Simple as that. Now, here's the thing. Not all authentication methods are created equal. They've evolved over time, and it's super important to know which one you should be using. In fact, EIGRP is smart enough to not even support clear text passwords. So let's see how we got from the old way to the modern standard. So let's break down our two main options. In one corner, you've got MD5. It's the old-timer. Yeah, it works in both configuration modes, but honestly, it's considered broken and it's vulnerable to attacks. Then, in the other corner, you have the heavyweight champ, HMAC SHA-256. It's modern, it's highly secure, and it's what you should be using. The biggest takeaway here? To use this stronger algorithm, you have to be using the newer, named mode for your configuration. And that is the perfect lead-in to the modes themselves. Classic mode is, well, classic. It's the old way. The configuration is scattered all over the place, some under the EIGRP process, some on the interface itself. It can be a real pain to manage. Named mode, on the other hand, puts everything in one neat, tidy place. It's cleaner, way easier to troubleshoot, and most importantly, it's the only way to get the good stuff like HMAC SHA-256. This is why it's the standard today, no question. Okay, enough theory. Let's get our hands dirty and see what this actually looks like on the command line. We're going to walk through both modes so you can really see the difference for yourself.
So with classic mode, you're doing this weird two-step dance. First, you have to go build a keychain, you define a key number and a password. Then, you have to jump all the way over to the interface configuration to actually turn on authentication and point it back to the keychain you just made. See how you're hopping around? It's a bit clunky.
And now let's look at the right way to do it. EIGRP named mode gives you this awesome, unified place to configure everything. IPv4, IPv6, all of it under one roof. It is, without a doubt, the way to go for any modern network.
So if we want the absolute best in security and manageability, we're going to use named mode with HMAC SHA-256. This is the gold standard. Let's build it out, step by step. Just look at how clean that is. It's night and day, right? You go into your named EIGRP process, drill down into the address family, and then into the interface settings. It's all logical, all in one spot. And here's a really cool trick. With HMAC SHA-256, you can just type the password right there. You don't even have to build a keychain, which can make simple setups way faster.
But speaking of keychains, just because they're optional for SHA doesn't mean you should ignore them. Using them actually unlocks some seriously powerful features. So let's level up and look at a pro technique for managing your passwords without ever causing an outage.
Okay, so here's a real-world problem. Your security policy says you have to change passwords every 90 days. But if you just go and change the password on your EIGRP neighbor, what happens? The connection drops. Your network takes a hit. Well, if you use keychains the right way, you can rotate those keys with literally zero downtime.
And this is the magic trick right here. It's brilliant. For a little while, you tell your routers to send packets using the old key, but to accept packets using both the old key and the new key. Once all your routers are ready to hear the new key, you flip a switch and tell them to start sending with the new one.
Because of that overlap, the neighbor relationship never even blinks. It's a completely seamless, hitless update.
Of course, let's be real. We're all human. Even with the best plans, we make typos. A mismatched password, the wrong key ID. It happens. So what do you do when it all goes wrong? How do you fix it?
Here's your troubleshooting toolkit. Your first stop is always show IP EIGRP neighbors. If you don't see your neighbor, you've got a problem. Next, use show keychain to make sure your keys are actually active. If you're still stuck, it's time for the deep dive with debug IP EIGRP packets and show IP EIGRP interfaces detail will confirm exactly what's configured on that interface. And when things do fail, this is the kind of message you'll see in your logs. Boom, the neighbor is down, and the router is practically yelling at you why. Auth failure. That is your smoking gun. It's your first, best clue that you have a key or password mismatch.
Now, if you turn on the debug, you get even more juicy details. This message is telling you, hey, I just got a packet that used key number 10, but I don't have a key number 10 configured. Then it says it's ignoring the packet. This pinpoints the exact source of the failure.
So, let's bring it all home. What do you absolutely need to remember? 1. Always, and I mean always, use authentication. 2. Stick with named mode. It's the modern standard for a reason. 3. Use HMAC CH256 for security. Just leave MD5 in the past where it belongs. And 4. Master those keychains so you can handle security updates like a pro without breaking a thing.
And that really brings us to the final thought I want to leave you with. Your network is a living, breathing thing. It's changing all the time. So the question you need to ask yourself is, are your security practices evolving right along with it, or are they still stuck in the past? Thanks for tuning in.